Seems like we've had a lot of new people join in the last few weeks. Raise your hand if this is the first time you've been to this meetup. Wow, awesome. So thanks for coming out, really appreciate it. And just so I can get an idea, everyone in the room, who would call themselves a web application developer? So probably 2/3 or so. Who else do we have in the room? Just shout out a couple of things if you're not a developer.
Business development.
Okay, business development. Anyone else? Just trying to get an idea of sort of who's interested in what we're doing. Founder, CTO, so too important to do real work.
Unemployed?
Unemployed? Cool. Well, everyone's welcome. If you haven't been to the meetup before, you probably saw on meetup.com, if you looked through the meetup stuff that we've done in the past, we tend to vary quite a bit in the topics that we cover. We try to keep it interesting. We definitely focus a lot on what we think will be interesting to web app developers. I'm a web app developer myself, and Corey Butler is the co-organizer of the meetup. So you'll see either one of our names on this. Let's see. Oh, it changed.
Sure.
Oh, is it on a different mirroring thing? Cool. I was just going to show the title slide. So obviously you guys know what we're talking about since you're here, hopefully. We're talking about AWS. As the organizer of this meetup, I actually have it's interesting to me because when people don't volunteer to talk about stuff, then I start looking around at things that I'm interested in. And I'm working on AWS myself right now, trying to kind of learn the ins and outs. And so Otter here has a company called Flux7, startup here in Austin. And I actually started working with him a little bit. He's helping me with my AWS deployment right now. And as we got into it, I said, wow, this guy's actually knows what he's talking about, and this kind of stuff that we've talked about is very interesting. And I thought, wow, this would be probably pretty interesting to other people in the same boat that I'm in, which is in my case, actively working on a SaaS type product and figuring out how to get it set up and run and deployed on AWS. And what I found myself was that, getting started with it is actually pretty easy. Log in, throw an instance on, a little micro instance, throw some code on it, and you're up and running, no problem. That's great. Well, when you're actually doing it for real, trying to build a company around a product and all that stuff, you very quickly run into, well, how do I deal with scaling, and how do I deal with backups? How do I deploy to staging, and then what do I do about production? How do I set up SSL, right? All that kind of stuff. So I don't know exactly what Otter is going to talk about, maybe some of that. But that's the kind of stuff that I've been finding challenging and interesting, and so that's why I thought this would be a good topic for everyone. Raise your hand if you're currently using AWS. Cool. Raise your hand if you have never used it, but you're just interested in learning a little bit about it. Cool. So most people have a little bit of experience with it. I'll let Otter take over from here. Actually, I have one. Forgive me for 1 second. Let's see. Is Ryan McGarry in here? No. So I got this ping from Meetup. Ryan McGarry put a comment on our Meetup group that there's a co-working space in Austin, chicone.co, and they have a 1K, which I assume is $1,000 AWS credit for joining their co-working space. So just a little announcement for anyone looking for co-working space who's into AWS, that might apply to you. So without further ado, I'll hand it over to Otter.
Thanks, Brian. So, actually, do I actually need the microphone, or can you guys hear me at the back?
Need it for the streaming.
Okay. Just wanting to free up my hands. That's fine. Okay. So many of you did mention that you have used AWS in the past. What I wanted to do was I'll actually go back a few slides, which was just a quick preamble. Most of the stuff is known to the crowd, but I just wanted to sort of give a big picture view and sort of share my terminology and set us all on the same page of what exactly is introduction to, what exactly is cloud computing and how and why it's become such a big deal. So, in one sentence, cloud computing has turned computing into a utility. You're no longer buying computers, you're just renting computers. It's very much like electricity coming to your home. If you have not seen it, there's actually a really interesting video by Stephen Fry on YouTube. Once these slides are posted, you can just click on the URL. He goes from 2000 BC all the way up to cloud computing in like 4 minutes and 30 seconds, explaining all the transitions that humankind have gone through, and he actually marks it, explains why cloud computing is such a big deal. He sort of compares it to the Industrial Revolution at the beginning of the century, and actually makes some really interesting points about how the two are comparable. So what does it mean? It means you do not have capital expenditure, you're no longer buying computers, it's just pay-per-use. You can dynamically scale the infrastructure. So instead of one problem with buying computers is that you have to know how many computers you're going to buy and what type of computers you need, so you don't have that problem with AWS anymore. You get a computer, and if that's not what you were looking for, it's just going to take 2 clicks to switch over to a different offering. And as a result of that, you're no longer guessing what you need to buy, which is a very big deal in terms of it's no longer a question of what I'm going to buy, it's just a question of just try something out and you can pivot yourself to the correct solution. Another way of looking at it is that so large enterprise and large companies have always had some of these things sort of as a requirement, necessary evil, whichever way you want to think about it. But they've had security, governance, they've wanted reliability, they've wanted scalability. Large company stuff typically used to cost a lot of money to set something like this up, required a lot of expertise, required a lot of hardware. But by getting into cloud computing, we basically changed that. And now it's irrespective of the size of the company or the type of the company, you can have access to the same level of resources or the same kind of resources. And we'll be deep diving in a second. But just keep that in mind. If that a part of it is being able to enable a startup, maybe a single-man startup, to achieve the same level of security, the same level of performance and durability as a large enterprise. So this is actually a quote from the AWS Summit. The message is loud and clear. Info, if you don't know who Info is, it's one of the largest software development firms in the world. I think they're capped at about 10 billion. Service about 100,000 clients all over the world, and this was their CEO talking, and Info has basically made a pledge that they will not write software for any other platform other than AWS anymore. And these are guys who write platform for banks and all the Fortune 500, so it's actually a very revolutionary statement in its own accord. So cloud computing, AWS. AWS was one of the first offerings for cloud computing. We still recall the first time I got introduced to it about 7 years ago. Just go in there and click your way to be able to get yourself a server. Actually, at that point, it wasn't even a web interface. How many of you have actually used AWS since like its really early days, 7, 8 years ago? So there was a time when there wasn't. What's that?
About 10 or 12 years ago.
Wow, so you really started early on. And there wasn't even a web interface at that point. You would just download a set of tools, and creating an instance was this long command line that you had to construct and just fire off.
Did you ever come back?
There was a microphone here.
Hello? Okay, let's try this one.
Okay, thanks. So the significance of AWS is that they were one of the first ones to introduce the concept. Since they've been around long enough and they've had good market traction, they have been able to improve and evolve very rapidly, and to their credit, they continue to add more and more features. I think they're still evolving faster than any other competitor right now. And what that has meant is, well, they're the largest provider, have most market share, Their interface is quite streamlined. There are no kinks. There are minor technological details which can actually make a very big difference if you're trying to put a deployment or trying to choose a cloud provider. And there are details that you won't realize until you go and do an at-scale deployment in a couple of different cloud providers. For example, the time it takes for when you click and say I need a server to when you actually get a server. It's very widely varies across different cloud providers, and AWS is a winner by almost an order of magnitude. Instances come back up really fast. Why would you care? Well, by the end of this talk, you'll see it in a lot more detail. But yeah, traditionally, you may be used to a model where you click and you say, I need a server, and then you have the server, and that's the server you live with for until the server, something happens to the server. That's the model we're all used to, because we're used to this idea of buying computers. What I pointed out earlier was it's a utility. Just like we don't buy power plants, we just rent them. So to you, servers are not something to just keep around. The idea is to just think of them as disposable resources. And at that point, you can actually make your operations a lot more efficient. If I don't need the server, just turn this off, because it's going to take 10 seconds to turn it off. And if I need it again, I'm going to bring it back up in 60 seconds. And those times begin to matter a lot when you're actually putting a large at-scale deployment, or you're setting up, say, a developer environment in Amazon. Rather than keeping it up 24/7, you can actually turn it off and turn it back on need basis, and those seconds actually begin to count. It's most mature and stable and has tons of features, and we'll be just going through some of those services today. So brings us to the topic of today, which is a crash course on AWS for application developers. Brian briefly talked about me, so I've been working with AWS pretty much since its inception, and have seen it go through and evolve over time. There is a lot of things that have been added, lots of features that have made life a lot easier, and we'll be just deep diving into that. So Brian already did the poll on this one, that I think we have backend developers heavy. Are there any folks here who are doing both operations and development, DevOps? So a handful. Basically, I think I'll try to target my talk more towards the backend developers, and then we'll talk about operations as we get into that. The other thing I wanted to sort of get a feel for, how many people here are working for large enterprise companies? Any mid-market, like not large, but like not a startup either? So we are mostly a small business startup crowd, is that right? Okay, great. So the reason I ask is because it does make a difference on how you look at AWS, and what your baseline is actually changes quite significantly. For example, if you're an enterprise, you would have concerns about how you are going to bill your internal customers. If you're a startup, you would not have those concerns. So different topics to sort of think about when you're moving over to AWS. So what exactly does AWS change? Just starting from the baseline of, and this is not really, it doesn't need to be a physical change, it's more a conceptual change. Working with a cloud rather than working with a traditional pool of servers, what changes is how you architect your application, how you actually do the development, and how you actually do the management. And architecture is the most significant of the three at the face of it. But the fact is that when you actually get into it, as Brian was talking about, when you actually go in production, the other challenges begin to surface about development and management. So we'll try to touch on all three. So let's start with the architecture. So here's a very simple way of thinking about it, where if you want to start from the whiteboard and you want to have a production-ready application in AWS, so I just split it up into three simple steps. You want to start with the whiteboard architecture, and then from there on go towards step one, which is just look at your whiteboard and try to see what there you could actually replace, and just use something that AWS is already offering on their menu. Look at security, and then leverage elasticity. As Brian was pointing out, a lot of people stop somewhere between step 0 and step 1, what's out here, at least in the initial phases, and that's where my startup clients, that's where they typically are. Step 1 gets accomplished in several cases because there's very tangible benefits for the developers. The developers see, oh, I don't need to write my own caching layer or figure out my own caching layer, I can just use the caching layer from Amazon. So they get to that. That's typically where most of the SMBs or startups would actually stop, is somewhere right after step one, before they actually secure the infrastructure. And I will talk about what it actually means to leverage the elasticity, so we'll just get into that. So just to keep the talk more use case focused, I basically created a simple web app. It's actually not simple by many means. It has several tiers. I just wanted to show what we can do with AWS and how it would simplify something like this. So just a web application, there's an application server, there's a web server, there's a caching layer. If you want this, you want to work, let's see. So you would have like some kind of a separate static storage layer. So typically you would put like Nginx or one of those tools to actually do some static storage separately from your dynamic application code generation. And then so you have web, you have app, caching layers for caching pages, caching layer for caching data coming from the database, the actual database. In addition to that, a modern application would have like NoSQL databases rather than just a traditional database. If you have an application where you're doing any kind of API processing or job processing, there would also be a queue. So just an application with different tiers and sort of a common set of what I've seen across clients. So I'm just curious, by the way, many of you said that you are startups and you are already working with AWS. How many are actually using NoSQL versus SQL? So how many are for SQL? So no, what about NoSQL databases? So about 50-50 actually. Is there anyone who's using both in the same application? Interesting. So I've actually seen that with in a few cases, so I was just curious about that. And okay, so you come up with, you go on the whiteboard, you build like an architecture, you draw these boxes and draw these lines. Generally simple stuff, nothing involved. And that's when the worry list begins. You have things that you need to worry about, that you need to take care of with that architecture that we have. So you have a database, you need to figure out a plan for having a backup. You need to have a backup for your assets, the files that you're going to put, or your users are going to upload, for example. You need to have a plan for keeping those around. You need to worry about the uptime of your web tier, because if your web tier goes down, we call it mission critical. If the web tier goes down, the entire website goes down. Uptime of the application DB, uptime of your static hosting tier. In addition to that, you have to worry about traffic spikes that may occur. There is a possibility of a denial of service attack, and there are possibilities of security breaches and hacking stories. By the way, I have a good one on the security breaches. Some of you actually in the audience have known me for a few years. I used to have a really small startup that really never got big. It was called ACC Deals. I did it right in the Groupon days when Google made that big offer to Groupon, so I figured that's a good way to go and make some quick money. Clearly did not happen, and I still drive the same car I used to drive even at that time, so that tells you the assertion on that one. But so I set up the website and everything. I was fond of doing stuff myself. I actually set it up. This was on a VPS host. Set it up using the Joomla framework, made it all pretty, bought all the plugins and everything. Got the site up. It was using Facebook logins. Contacted the ACC guys. It was directed for ACC students. So I got in touch with them. They were having this, ACC has this night every year where they just have this large extravaganza with about 10,000 students showing up, something on that order. So they have this annual event. I said I'll be a sponsor. I had allocated myself a budget of 10 grands for this self-funded. I ended up doing a few grants on that event. I'll be setting out flyers, I'll be doing all the good stuff, and I was expecting that it's just going to take off after that night. About 2 hours before the event, and I did not even realize this, somebody actually hacked into the website and actually brought it down. So the event happened, the flyers got distributed, every single one of them showed up, because I actually did see access logs later. I had over 1,000 hits that night, not a single one got a service from the website. and I ran out of money, and the startup went down. So, important lesson learned. Yes, you do want to worry about security as soon as possible, because if something like that happens, even if you're a startup, you may think that it's a success problem. Well, if it happens on the wrong day, it could really change the fate of your company very soon. So, you do want to worry about security. So the first and naive implementation, very much what Ryan was getting at, is take your picture that you drew on the whiteboard and just translate what I would call a one-to-one mapping roughly. Every box on my whiteboard just turns into a server in AWS. I just bring up n servers. Every server has its own IP address. I just connect. I bring up a server. It's no different from going to Dell and buying a box and putting it in my garage and just turning it on. Gets its IP address. I give them, every server has a fixed IP address, and I just connect them by setting IP addresses in my application. And I expect it to just stay there. I expect the application IP addresses are going to stay the same, the servers are going to be there forever, and I can just keep using stuff from there on. So I see this a lot, actually, with hard-coded IP addresses inside the code, hard-coded IP addresses inside like actual code, Ruby or Python code sometimes, where people would just assume that their memcache tier is not going to go anywhere, or their varnish tier is always going to be the same IP address, so it's just literally put in there. Well, that's fine. That was fine with the old mindset, and yes, the AWS servers, once you bring them up, do not go down on you right away, but the fact is that there is a high probability, and there are no guarantees that they won't go down. In fact, AWS makes it very explicit, if you read their SLA, that if you have an application that's only using a single availability zone, so AWS has their failure domains set up so that it's multiple regions. Inside each region, there are multiple availability zones. If you have an application architected such that it's only using a single availability zone, or has a mission-critical tier that is on a single availability zone, if Amazon pulls the plug on that availability zone and it's only one availability zone goes down in that region, they don't owe you anything. They will not technically not take your phone call at that point, because that's not a support problem. They will not owe a refund. They will not owe you an apology. And if your entire application is hosted in a single availability zone, your entire application can go down, can stay down for as long as AWS is trying to fix the problems that they've had. And they would not owe you, basically it's clear in their SLA that they would not owe you a refund or anything. So you have to be smart about leveraging stuff. So a simple one-to-one mapping, several things wrong with it, and one of them is just that you would have single servers with every tier, and you could run into this SLA problem, and it has happened where Amazon availability zones have gone down. Yes, sir?
So you balance it out with an elastic balancer, Cat?
We will get into that. So we'll take this architecture and I'll try to more AWS-ify it as we go, add more stuff to it. So although it's, like I said, it's a one-to-one mapping, and really take whatever you have on-premise or whatever you have on your laptop. If you have a startup, you're probably running stuff on a Vagrant box on your laptop. Just convert one-to-one to AWS. It still helps, because Amazon does actually provide some basic denial of service attacks for you, covers some basic denial of service attacks for you. So it's better than like buying 4 servers and just setting them up in your garage without putting a proper firewall in front of them. It's not enough though. So the next step, which is what I called step 1 earlier, was try to, and this really applies to startups, by the way, where you are building a greenfield project, you're just building it up. Just identify pieces where you can leverage pre-built stuff in AWS, where they're just offering it as a service, and try to maximize the usage. So take this picture and convert it into this. I have several services labeled over here. So notice I just draw your attention to a couple of them, and then we'll deep dive into each one of them individually. So there's RDS. RDS is basically traditional databases like MySQL that you can spin up, and Amazon will take care of things like backup. You could set it up so that it can have high availability, and it can have a replica in another availability zone. So if one availability zone goes down, you can bring up a replica of your database in another availability zone. And these are very simple things, like when you are setting up an RDS instance, it's just a few extra clicks that can actually buy all of those things for you. So similarly, we noticed that we replaced the static storage with S3. So S3 is this object storage service that Amazon offers. High durability, very high availability. They sort of take charge of that from there on, and you will not have to worry about backing up your assets and actually figuring out how to actually save them. So let's deep dive into each one of these services one by one. So first we have Amazon EC2, which is where AWS started, the Elastic Compute Cloud. So EC2 is basically where you go to get your servers. So there are three key concepts here. There are servers, which is also known as instances. You just bring up a virtual machine. They call it an instance. Really reads and feels like a server when you're using it. One of the nice things is that it's a virtual machine, so you can take an image of this virtual machine and just use that. So you can take a server that you're running and snapshot it and turn it into a virtual machine image that you can later bring up. They refer to that as Amazon Machine Images, AMIs. And lastly, there are volumes. They're called EBS volumes in Amazon jargon. You can attach them to one of your instances, and that's where you want to put your data that's dear to you, because EBS volumes are independent of the server. Even if the server goes down, EBS volumes are independent, and they can actually stay, and you can attach it to a new server when you bring it up. Also, you can actually take snapshots of your volumes. And this is something that, for those of you who are using AWS, how many of you are actually taking regular backups or taking snapshots of your servers or your volumes? So I see a couple of heads nodding. Very few people, I assume. So this is something I highly recommend. Very, very easy to do. There are some very simple services out there. It's like a 3-line bash script to actually write this on your own if you want to set it up as a cron job. And when I say 3 lines, I'm exaggerating because I'm actually counting the first line where you specify the interpreter. So if you actually just put that in a cron job and just set up something for a nightly backup, just simple, nothing fancy going on here, that can actually save you a lot of trouble. You may think, yeah, I mean, my servers, I can just create them again whenever I need, but then think about what you could do with that time if you did not have to recreate your servers from scratch the next time. So just take a snapshot of your disk image, set it up. Snapshots, AMIs, cost very little, pennies a month, typically. And snapshots for volumes are actually incremental, are saved incrementally, so it's not even a lengthy process. It only saves the changes that happened from the last snapshot, so it's just a layered thing to do. If you want to go that would be one of those things I would say. If you're not doing it, it's a very high ROI on that, because it'll at least save you a few hours one of those days when your server will be accidentally terminated. Yes?
So it's all incremental?
The snapshots?
Yeah.
Can you repeat the question?
Sure. So the question is are the snapshots actually incremental, like when you actually take a volume? So you actually pay only for the delta. When you take a snapshot and you already had a snapshot, say, taken yesterday, you pay and you take another one tonight, you'll be paying only for the delta.
And what happens if they lose one of your increments? Like if you took it every night, is there any chance they could lose an increment? And
like they wouldn't, I mean, they have very high SLAs on that. If you accidentally delete, actually, have you tried that?
On S3, so the durability is 11 times, so then losing it is very unlikely.
okay.
And what happens if you delete it accidentally? I've never deleted it.
Nothing happens because it will.
There's a differential.
So it does keep track of, okay, this is a dependent. So A is dependent on B. You delete B. A still maintains that dependency. It will merge it together when it can, but it doesn't actually lose it.
Okay, so just to repeat the conversation for the guys listening on the streaming side. So the question was, are the snapshots incremental, and what happens if you actually lose an intermediate layer? So the chances of Amazon losing is really low because they're saved on S3. As I mentioned, S3 was one of the services I talked about earlier. And S3 has a durability of 11 nines. So I think their exact phrase, if I remember from the website, is that, yeah, if you have 1 million items on S3 and you let it sit there for 1,000 years, there's a chance they would lose one of them. So that's basically the kind of durability we are discussing here. Just a second, And so the chances of them losing is low. If you actually accidentally lose it, it still has the dependency information. So a snapshot, like let's say you had A, which was an incremental from B, which was an incremental from C, and B was deleted, A would still maintain the information from A to C and will be able to recreate it. So you would actually not lose the data. Yes, Steve, you have a question?
Another option you made was the multi-region copies too. If you had really critical data.
Absolutely. Yeah. When we are talking about backups, thank you for bringing that up. Yes, you should back up not just in the region that you are in. In fact, it's almost more important to back it up in a different Amazon region. And when you are writing that one-line script that I mentioned, it's really just minus region and just set a region to be in a different region, because that gets you two things. A, you have a backup, but B, you also have some disaster recovery plan where if one of Amazon's regions goes down, you could still recover your data from another region. In fact, I got a really interesting insight on that one we were dealing with a client who had some PCI compliance requirements. So they're a credit card company out of the Bay Area. And they have very strict logging requirements. They have to keep every single transaction log for 5 years. It's just required by the federal law. So they cannot afford to lose anything. And one of the recommendations as a part of the solution that we built for them came out to be that you not only want to save it in a different region, but you also want to make a copy in a different AWS account for which nobody has credentials except just one person in the company, perhaps the founder or the CEO himself. The reason there was that what if you have an employee who gets disgruntled and just deletes all your backups? Could get you in real trouble. So you always want to be making a nightly backup, not just in another region, but also in an AWS account solely for the purposes of backup. So that's something I learned just a couple of weeks ago, which I thought was very interesting and makes a lot of sense. Yes.
What keeps me up at night? Well, not really, because I don't care that much. But if I were to use EC2, is if you go back to the previous slide, when you start swapping out the services to RDS and S3 and all those fancy scalable things, is that you are basically selling your soul for convenience in terms of lock-in. Are there many tools you would recommend that are basically intermediary layers that you can plug these services in and out as you see fit?
So I actually would classify Amazon services.
Read the question. Por favor.
Yeah, so the question is, how would you actually avoid a lock-in into Amazon as we start drinking the Amazon Kool-Aid and start moving over? So I would actually say that there's some of these services are like very intrusive, if you will, and they would actually require you to change code. But then at the same time, not every service is like that. In fact, at the end of these services, let me quickly jump to it. I had actually put a small discussion, and I was planning to talk about that later, was what are the criteria, whether or not, because yeah, I went ahead and transformed everything, but that was, like you pointed out, it's just taking Amazon all the way. You may not want to do that. There's pros and cons of doing it. And one of the negatives definitely is the lock-in. So you really want to split the Amazon services and sort of look at it as services that are gonna require you to really get stuck, if you will. So for example, DynamoDB, let me go back to the slide with the tiers. So DynamoDB is one of those, for instance. It has its own API. There isn't equivalent API, which is open source. So if you actually, and it's gonna require you to change code. So you change your code, lock into DynamoDB, and now if you want to get out of it, you're actually going to be stuck with it. On the other hand, there are services like RDS. RDS is just MySQL managed by Amazon for you. So not necessarily a bad idea to do something like that. Elasticache, just Memcache managed by Amazon for you. CloudFront is actually not intrusive in that it's literally something that sits between the user and your Apache or your web tier. So you can always pull it out and your application will still work without it. So while it's kind of like makes sense to not, it does make a lot of sense to not go all the way, at least right away, and think through these decisions. And that's what the 3 criteria I had was, and I'll get back to that slide in a second, of what I think you should keep in mind when you're actually making those decisions. DynamoDB is a particularly good example on things that you want to think seriously before you jump into it. It's really good. But then I've seen people had trouble with it, not so much because of the lock-in, but it can get really expensive really fast when you really scale up. So you want to be cautious of locking in. Yes.
Just to kind of piggyback on that question, and maybe you're going to address this later, but just kind of maintaining parity between production and development environments with AWS. I'm kind of curious. You sort of hinted at it already that some of those are just kind of analogs for other services that are out there like MySQL. But as far as just kind of replicating what's actually going on in production locally, sort of something I'm not going to answer to through AWS exactly.
That's actually an excellent point, and I do have slides on that later, because that is a problem we run into a lot as well. I'll talk about it briefly, and at least some of the solutions that we have seen work for us. But DynamoDB, the reason I know about that exception is because I know that that can become a challenge really fast. So leave that discussion for later. So the second service, just to touch on, is just having a traditional database. It's not so much as a service. I guess I could level it a little better. It's really the idea that they will bring up a server for you, and then with one click you could set up a backup, and just back up in a different region or a different availability zone, or you could get a high availability setup done for you. And those are things that are actually really time consuming and a pain to set up otherwise. And that's exactly where I think if you're a startup, the cloud, sort of my point earlier about high availability MySQL setups are a very common thing. They've been around for a very long time. For the large enterprise, they've had it all the way. The question is, you as a startup now can actually have it with 2 extra clicks, not an extra investment in terms of money, which is a very big game changer. And at the same time, I would also then argue, like my point about backups earlier, that if you're not doing it, you're not really taking advantage of a platform that you're already on with. Clicking those 2 things, you're sort of opening yourself to a risk. And I am kind of a naysayer when it comes to like the argument that we are a startup and we don't care about our data, or we don't care about our server going down, we can always recreate it. Because as a startup, the most important resource you have at that point is the number of hours in a day. And every one of the founders in the room would appreciate that. So if if you can save a few hours by making 2 extra clicks at the right time, it can actually make a very big difference to your overall agility of your company. So it is important to think about these things as early as possible. And yeah, even if it'll save you 15 minutes, why not, right? If it takes 30 seconds to perpetually save you 15 minutes and can save you multiple times, why not do it? Caching layer, so this is very much like Amazon CloudFront is very much like Varnish, just sits between your servers and your user, and like literally sits in between, takes whatever, when you supply something to the user, it sort of saves it in itself, and then later if the user asks for the same content, it can just provide it from there. I would safely say that this is one of the most underappreciated services that Amazon has to offer. Very few people are actually taking advantage of it, in my knowledge. How many people in this room are actually leveraging CloudFront? Good thing actually, because it's, are you guys doing it just for static content or dynamic content?
Static.
Just for static content. That's the first use case, and that's a great first step, in fact. Just to deep dive on that a little. So CloudFront, as I mentioned, is a layer in between. Take something from a backend origin, is what they call it. So if user asks for, say, file a1.jpg, it'll take it from the origin, save a copy locally, and pass it on to the user. Now, when the user asks for a1.jpg again, it'll just be serviced by CloudFront. The reason I said it's underappreciated, because very rarely do you actually have a component in your architecture which, if done right, can save you money, can improve the performance of your application, and can reduce the load on your servers so that you have less management overhead. So it literally, and it actually even improves reliability, because even if the origin goes down for a short period of time, CloudFront can continue to service your requests from your consumers. So reliability, lower cost, and less management, and higher performance. I mean, there's not really another service out there that can actually give you all of them at the same time. So it's worth investing in it if you're not looking at it. Static content is the first step, where you use the a1.jpg. There's the next layer to it, where Amazon has now added dynamic caching to CloudFront as well, where you can cache entire dynamically generated HTML web pages. So for something like something simple like our website, flex7.com, it's sitting behind CloudFront right now. It's a blog, we update it about once a day, we get comments here and there, so the update frequency is not that high. So when you actually hit flux7.com, the page load time is on the order of like 300, 400 milliseconds if you have a decent internet connection. And a big part of that is because it's actually always serviced from the closest CloudFront endpoint, wherever you are in the world. If our server at the back end goes down, doesn't really matter, it'll get serviced from there. If we get a spike in traffic, CloudFront will continue to service it for us. We could be running it on a T1 micro, paying 2 cents an hour to Amazon in the background, but most of our traffic will be serviced from CloudFront. And we would not have to worry about that. Reliability, very low in cost. The cost turns out to be practically zero on the Amazon monthly bill. So, and it also gives you this geographical distribution. So if you're not using it today, I would definitely encourage you to consider it, at least for the static content, but ideally you want to think about dynamic content. And if you're a greenfield project or if you're a startup, this would be one of those things you want to keep in the back of your head. If you can separate content on your website, which is actually dynamic and needs to change very frequently, from the content that is typically static, it may be HTML, but it's typically not changing by the minute. It's a great idea to think about those two contents separately, because that's where that's what I would call code with caching awareness in mind. Because if you can separate the relatively static, it doesn't have to be completely static content from the real dynamic content, you could apply caching on the static content. And think about what it does to your application if we go back to the picture. If you can service most of your requests from here, the request never actually hit your web server, which means you can run this infrastructure a lot leaner. This is infinitely cheaper compared to actually running more servers over here, and you don't have any additional management overhead for more servers. So for a greenfield project, it's definitely something to think about. Elasticache, it's basically just adds a caching layer. So Memcache or Redis. Did you have a question?
Yeah, I was going to ask.
So
does it cache across all availability zones? Is that?
So the question is, does S3 cache across, does CloudFront cache across all availability zones? So when you actually set up a CloudFront distribution, which is what they call, like when you set it up to say when this URL is hit, go to this origin or something, they actually give you a choice where you can check like you want it cached across all over the world. You can have it cached just in North America. So you basically get to choose where you want it cached, and you pay more if you want it cached all over the world. I think last time though they had something like 43 different endpoints distributed across the world for CloudFront, but that number continues to go up by about 10 every 2 or 3 months. So Elasticache, it's basically just in-memory caching tier. The typical use case I see for this are two. One is caching results from your database if your database is not changing very frequently. The other one is session storage, so session cookies and stuff make really good candidates for just storing in-memory caching tiers. So anyone here actually using Memcache or Redis or Elasticache? So
Redis.
Redis? Yeah, Redis is actually a great tool. So yeah, definitely consider the Elasticache. Although Redis and Memcache, I guess this one is kind of interesting in the criteria that we were going to talk about later on, which tiers to actually swap out. Redis is actually pretty easy to install. It's one of those applications that I think they've done a really good job at. You can set up a Redis server on the order of seconds. So you may want to consider doing it yourself, but still you have the management overhead. So it may make sense to let Amazon do it for you. And you can create a Redis, Elasticache, or Memcache. Are you using your own Redis server or Memcache? Amazon's?
Everything's on Iron where I work.
I see. All right, so the next service, Amazon S3, we already talked about the durability on this one. Same thing for availability. It's fast, so put your static content on there and you just not have to worry about it. Yes?
What is the difference between availability and durability in this context?
So availability is that the service stays up, you ask for an object and you are going to, 99.99% you're going to get the correct response. Okay. Durability means that you put an object there and you have 1 million documents there. How many are you going to lose in 1,000 years? Like I said, you'll probably lose one if you leave it there for 1,000 years. So with S3, they have basically, again, policies you can set on how many different replicas of your data you want. If you want more replicas, you can actually tune your durability and costs. So you can get extra replicas created, geographically distributed with just a few clicks, pay a little more and get very, very high durability. So you can sort of choose between the trade-offs. There are actually some projects, going back to an earlier question about lock-in. I think S3 is one of those services, by the way, where I would say it's almost worth the lock-in, because you can use it even if you move out of AWS tomorrow. You could still continue to use it. Extremely cheap, prices are going down. They reduced it by 51, the prices on S3 got reduced by 51% recently. So it's sort of worth investing in it, and it's really easy to sort of work with it. Every single language today has some kind of an S3 adapter. So whatever backend language you're working with, or even if you're writing an iPhone app or an Android app, there is an S3 adapter out there. So very little overhead to use it. Really good service, practically no cost using it over a long period. And then if you want to switch out, you don't have to switch out, but if you have to switch out, again, just replace it with a different adapter and you should be fine. Just need another object storage underneath. Again, if it's not something you're heavily using, at least I have one story to share on this one. I actually have a friend who got this crazy idea that he could make money by putting ads on WordPress blogs, not the first guy to get the idea. So he bought like 1,000 domain names from GoDaddy and created like 1,000 WordPress blogs and put like hired writers on otis.com, got them to write stuff, and soon enough he had 1,000 websites that he was paying the hosting for, which was coming out to be thousands of dollars a month. And with thousands of dollars a month, his income was roughly about $3 a month. So it wasn't working out really well in terms of the ROI. So what he had to do was actually, and this is something he accomplished in one night, which was very impressive for me. He actually just figured out, like WordPress has really good integration with S3. So he figured out basically how to move most of his content, all the static content, because his blogs were not changing. These were just not really blogs where people were writing comments. They were like, I wish I could remember the name of them, but like one of them I think was like white wedding gowns or something.com. And like this is just 5 pages worth of content for every one of these sites. So he actually moved text files, HTML files, he just took static dumps, wrote some scripts and pushed it all into S3. So his 1,000 blogs started getting hosted from S3 directly. The cost went down from $3,000 to I think $1.11 per month, because it was really very little data. There was no point of generating those pages over and over dynamically. And he can now keep it running, and now the business is technically profitable because he makes $2 a month on it. That's not bad for a startup, right? 300% profit margin. And he doesn't have to do anything, so there's real ROI. So. DynamoDB, we talked about it briefly. It's very much like Cassandra. In fact, Cassandra was inspired by DynamoDB. A really good product, except the challenges I mentioned earlier. It does require a bit of a lock-in because you will be changing your code. In fact, and you will be dealing with, I know that the prices actually go through the roof once you go beyond a certain point. So it's kind of a bad trade-off in some ways, because once you lock in now, once things are going to be good for you, you would be locked in, and that's when you'll start paying the big dollars. So it's something you want to think about before you actually go invest your resources into it. But again, no qualms about the product. It's actually a great product. I think it's one of the best NoSQL databases out there. There are some other services which we did not actually have on the picture, but I think are worth knowing about or using. So Route 53 is a very popular one typically. How many of you are using Route 53? I'm surprised actually. I typically see most of the clients I run into are using Route 53. So are you guys using like GoDaddy, or what's the typical, where are you setting your domain name servers typically?
GoDaddy, Cloudflare.
And just use their setup. Cloudflare, by the way, I've actually not used it, but I've heard really good things about it, so I should definitely play with it one of these days. What's that?
It's fantastic.
Yeah, I've heard really good things about it, and they have their security stuff all put into it, so it's one of those things on my to-do list. So Route 53, I think I like about two things I like about Route 53 and doing it the Route 53 way is that you get everything inside a single window. You log into Amazon, you get access to everything, and you can change things. The other thing is that you get this unified Amazon API, if you will. So if you want to do it from the command line or write scripts to manage your DNS settings, then this does offer a very big opportunity. You would think that you don't want to manage your DNS settings frequently. Like, why would you change your subdomain names frequently? People who are in the SEO business would tell you that it's actually one of the most powerful techniques. So if you actually do change your DNS settings and actually take the keywords that you really want to go high on Google and actually put that in your subdomain, at some point you'll get tired of doing it manually if you have thousands of them. So you would want something like Route 53 and write an API. I'm not suggesting that you do that because Google keeps on changing their policies, but I know that there is some real benefit to, if you're in the SEO business, it's a pretty big benefit. SNS, how many of you are actually leveraging SNS? Typically a very low number on that one. And SNS is basically simple notification service. So Brian, you're using SNS, by the way. Yeah, I want to be sure you know that. As you mentioned, he's one of my clients. So with SNS, it's basically just a very simple notification system. You could do it all yourself. I remember the days when, this was when I was at AMD, and the experiments I would run would finish in the middle of the night, and I was just annoyed by the fact that they would finish in the middle of the night. I wouldn't know what to, if the results came out good or bad. So I actually had to write scripts for it to send me email, which was just simple Unix mail at that time. Then I got a bit overzealous. I wanted it to be able to send me a text message when my job finished. So Google Voice, I think, had just came on board, and there wasn't really an official API, but I hacked my way through it and figured out a way for Google Voice to send me a text message when I wanted it, when one of my experiments finished. So, and then when I was playing with the iPhone stuff in 2009, around that time, I got this crazy idea of building an iPhone application where I'll make it easy for sysadmins to send notifications to their cell phones, just make a very simple API where you could just curl to something. So thank God I did not actually invest the time in writing that app, because Amazon actually solved that problem really well with SNS. So very simple API, you can just have SNS send you an email or a text message or an iPhone notification, whatever you wanted to do. You can just go in there and just check and say, just send it to my iPhone. Set up what you set up as a channel. Once the channel is set up, you just have an API from your server or from your code. Just you can have a one-liner that will trigger that message to be sent to you. So it's I kind of made it important, distinguish here. There's the server-to-man communication, the example that I just mentioned. You can also use it for server-to-server communication, which is that if one server wants to send a notification to, say, your Nagios server or one of those other services, it just wants to get a message across saying, hey, something's wrong, or one of those alerts, it can actually use SNS for doing that. Also have SQS. This is a, not yes, please go ahead.
Sorry, just curious, how would you handle on the other end to send the message?
So Amazon has it documented. Basically, the message comes to you in a very specific format. So to give you an example for the server-to-server communication, one possibility is that you may want, like, if a particular server is hitting 100% load on CPU, you may want to have a simple script that just kills that server and spins up a new one. And by the way, you may think it's a ridiculous use case, but apparently that happens on Wall Street. So on the I remember the story from a few years ago. I'm not sure if it's still valid or not, but on the Wall Street, they would actually write applications which had memory leaks in them, and they didn't have time to fix them. So what the solution to that was, they knew the market opens at a certain time in the morning and closes at a certain time in the morning. So they would run those servers and buy enough RAM that there will be no garbage collection by 5 p.m. By 5 p.m., the entire physical memory would fill up. No garbage collection has occurred the entire day. So at 5 p.m., somebody would just go and push the reset button on the server and just restart. The memory will just be cleaned up. So if you want to do something like that, for example, when you hit 100% in memory, just have somebody restart your server for you. So one possibility is set up CloudWatch, which is the Amazon metrics thing. CloudWatch can generate a notification using SNS. SNS can, one of the possible delivery points for an SNS notification is, like I mentioned, text messaging, and others are there. One of the possible delivery points is an HTTP endpoint that you can provide it. So basically what it can do for you is it can post a particular message to an HTTP endpoint that you specify. And then that, on the receiving end, you could have a simple, something like maybe a Node.js application takes the data that was posted, and based on that, make a decision, and maybe we send a restart command to that server that just hit 100% on memory. So the key is to be able to write that with something that can actually take that HTTP post/GET request from you. Actually, not that difficult. Amazon has done a good job of documenting what you need. There's only a certain type of fields, like where the message is coming from, what time it was sent, and you can just take it from there and make a decision based on that. Then the next thing is SQS, a rarely used service. Anyone here use SQS? Okay, so we have more people with SQS than SNS, in fact. So it's basically if you're doing any kind of job processing, it's just a queuing service. Could do the same thing with RabbitMQ. If you don't want to do it yourself, you can have Amazon manage it for you. And it's again one of those things where I think it's a win. The lock-in, there is a mild lock-in there, but it's actually a win because there are adapters for SQS for different languages. The cost is really low. It doesn't become a problem down the road when you scale. And RabbitMQ, setting up a highly available RabbitMQ with the possibility with like keeping in mind the Amazon availability zones and stuff, it could actually go down on you. Getting it all right to have high availability, we actually did that recently for a client because SQS is apparently not a service that's HIPAA compliant. And this was a client that actually needed HIPAA compliance. So we had to set up a RabbitMQ server for them, and we wanted it high availability. So you had to put it in an auto-scaling group and set it up, and it's not to get it to a very good, the same level as an SQS is actually a difficult task. Simple workflow. Anyone here use simple workflow? Boy, I knew that for a fact. Nobody would raise their hands on that one. If you read the document, you will know why I said that. It's horribly documented, really difficult to get it set up for once. Only 2 companies I know in the world who are actually using it. I'm sure there are more, but the 2 that I definitely know are using it: Amazon themselves and Netflix. How many of you know what SWF does actually? So SWF is basically a workflow engine. It's an orchestration engine, if you will. So the idea is that you can create a workflow in SQS where you can say, like, I want X happening, and then after X, I want Y to happen. Depending on the outcome of Y, I either want Z happening or W happening. So you can set up like this workflow, if you will, as the name suggests. And the idea is that you can set it up with simple workflow. And simple workflow is just sort of a state keeper for you. It keeps the state of the process in itself, and your what they call actors can actually communicate with simple workflow. So to just carry forward my example with A, B, and C, if you have 3 stages in a particular process, you will have an actor for A, an actor for B, and an actor for C. And all of these actors, if there is some work to be done by A, simple workflow will tell A, hey, do this. Similarly, if there's work to be done by B, it will tell, hey, do this. And as soon as the actors finish the task, they go back and enqueue the results back with a simple workflow. So it's just a way of setting up a pipeline. There are several processes that map really well to this. So it's one of those services which, if they are documented it better, I think would be used a lot more. And one of the processes that I've recently been kind of intrigued by is the actual process of continuous integration and continuous delivery. If you're actually trying to do continuous delivery, it's a process, if you think about it. It's not really one shot. Like the way we typically, all of us are doing it is, this happens, then this server talks to this server, then this server talks to this server, and this server talks to this server. And how many of you actually have like a continuous delivery setup working for you right now? So what happens when it doesn't work? You push something and it doesn't show up on the other side. The triage is the pain, right? Three servers
into the server, and
it could be GitHub and send the webhook, or it could be something else. You have no visibility into the different parts of the process that actually happen. Same things on your website. In fact, checkout processes tend to be that way as well, where you're communicating with the Visa or you're communicating with the financial companies. If you actually have a credit card-based checkout, there is a process to it. Like, if this happens, do this. If this happens, do this. And you write this spaghetti code. You have servers communicating with each other. It all can be architected together without any workflow orchestration tool. The problem becomes is when something goes wrong and you have no visibility into where the process actually broke. And that's where you get into those logs and analysis of the logs. So simple workflow is a very powerful tool for actually taking a process and converting it into a workflow, if you will, where you actually will have logs, execution logs for every single entity that passed through the process. And one of the things that's interesting is those actors, the only requirement on the actors are they grab work from the workflow engine, and when they are done with the process, they actually queue the response back to workflow. And what kind of really intrigues me about that is that it does not have to be actually a process that pulls it. An actor can be a human being. The only requirement is it's an entity that grabs what needs to be done, does it, and when it's done, pushes the result back onto simple workflow. So it could be something like if you're a mortgage broker and there are different steps. I'm buying a house, so that's why I mentioned mortgage brokers first. So if you actually have these different steps in the workflow process, you want signatures from 3 different entities, then it can actually be done such that they get an email from the simple workflow engine. Here you have something to sign, they sign it, gets enqueued back with the simple workflow. And if they don't sign it, the simple workflow can be set up to send reminders, it can be set up to send timeouts. So the entire process can actually be managed with it. So very powerful tool, very difficult to read the documents. So, but I would, if you have a process in your application, definitely something to think about. So now that we actually have this, we just went ahead and replaced some services with Amazon services, and some things on the worry list are kind of clearing up. So the database backup, yes.
The mic off. Try holding it in.
So yeah, the worry list begins to green up a little, where you have database backups that were taken care of by RDS. We have the assets backup, which was taken care of by S3. We have the uptime of the database, again RDS. Amazon manages it for you. Uptime of static hosting, S3. And the denial of service we got just by being on Amazon. And but we are still left with certain things about uptime of your application, your website, your web tier, traffic spikes, and security breaches. So let's jump into that next. So this was the discussion we started having, and just quickly touching back on it. So whether or not you want to replace a particular tier, it's a multifaceted decision. You have to think about if it's going to require a code change or not. Can you, first of all, what is kind of like to approach it with the process? What is the availability requirement really on this particular tier? Like if it's a caching tier, it's a much lower availability requirement than if it's mission critical and it's the database tier. Once you know your availability requirement, you want to decide if I do it myself using servers, will I be able to get there, or is it just easier to let Amazon do it for me? And the last one is, what exactly is going to happen in terms of code changes? If I do it myself versus if I use Amazon, how much code will I have to change, or how many new things I have to learn? By no means am I recommending use everything from what Amazon has to offer. Some services are more advantageous and a no-brainer compared to the others, but you do have to think about your own scenario. So the next thing, security. And as I said, after the first is where most companies would stop, typically startups, I've noticed that. So the next thing we're going to just jump into is the security stuff and what Amazon has to offer. So there are several things. I just put like just a couple of them here to get the idea. So I assume everyone here is using a security group. Everyone who's using an AWS has played with a security group, because it's a requirement. You cannot spin up a server without having a security group. How many of you are actually cautiously opening ports on the security group when you're dealing with that? So it's one of those things where Amazon's done a good thing. They sort of force you to say everything starts out by all the ports are closed, only port 22 is open. And then you can go in there and open more ports as your application requires. How many are actually using VPC in their infrastructure?
VPC.
What is VPC? It's basically virtual private cloud, so you can set up your own sort of a network, internal network inside the Amazon cloud. So why is this interesting? Because so the idea behind VPC is just like I said, it's like setting up your own cloud. By the way, if you haven't used a VPC yet, you definitely want to get into it, because Amazon's actually leaning towards disabling the ability, just like security groups, you will not be able to spin up instances without a VPC. They are really going in that direction. So today, if you spin up an instance, it's by default in a VPC. It is in a VPC, but that VPC is called the default VPC, and it does not actually lock down any ports today. But the idea is that they want everyone to be using VPCs, because what that does is for everyone, for your own virtual private cloud, your own network, you can basically have this secluded entity, and within it you get your own IP addresses, your own private IPs that you can actually set, and security settings on the VPC itself. Within the VPC, then you can have multiple subnets. So I think the idea, the closest analogy to a VPC would be like having your own data center or your farm of computers. Inside it, you'll have different subnets configured. So you could do the same with a VPC, and you'll have your own 10.x.x.x IP addresses that you can assign to your servers statically or dynamically. The biggest benefit you get out of it is security, because basically means your servers are no longer accessible to the outside world. They do not even have a public IP address anymore. So for someone to get to your servers, they have to break inside your VPC, so they can actually, they will actually be able to see, try to do a brute force attack on your servers. Yes?
It's 128-bit encryption, ABC.
On the VPC, actually, yeah. Is there even encryption on there?
It's under software defined system. I'm not sure if there is.
Yeah, I believe there isn't actually an encryption. Steven, what do you know? You're the security.
If you're in the virtual private network, in order to get into it, you're going to have to break something, right?
Yeah.
So it's talking amongst themselves, the different machines. So if someone were to break in there, what size encryption does it have between? Or is it just a process in a firewall rule?
It's almost like a VLAN. It's almost like a VLAN. It's segregated at like the hypervisor level of Amazon's network. So encryption is kind of out of the question at that point, because it's just the way it's segmented. Now Amazon does offer VPNs that you can VPN to the VPC to extend it to your network to connect it with the data center with a hybrid design. Or like what Otter was saying is, for someone to break into your website, get into your VPC, it's like they are going to see your website has a public IP, and so it's utilizing resources. There is that chance they could come in and somehow take ownership of the Memcache server within the VPC and have access to VPC, but that's a very unlikely scenario at that point. Does that summarize a little bit?
Yeah, so just to repeat the question and the answer. So the question was, does the VPC have 128-bit encryption? And the discussion we were having was basically that Amazon does actually allow you to connect to the VPC using VPN. And there you'd obviously have, that's an encrypted connection from, say, on-premise or your laptop or to the VPC. But the main thing about the VPC is the fact that it sort of isolates the environment, and you get your own your own network. You can get, in theory, you cannot get into that network unless you either VPN into it, or there is like a bastion server that you set up so that you can actually SSH and get inside the VPC. So the servers inside do not really have visibility outside the VPC. Again, it's a free service. Setting it up, by default, you already are using VPC, even if you say that you're not using a VPC, because all Amazon servers are now inside VPCs. And the idea is and when you say that you haven't used a VPC, what you really mean is you haven't actually gone in and looked at the settings for the VPC. You could secure your entire network and just leave only certain ports open, and then spin up servers without public IP addresses. For servers that don't need public IP addresses, for example, your MySQL server, which is only going to be accessed from your app server, and that's your database, so hence that's the one you want to secure most importantly anyways. Just assign it a public IP address, and your application server, as long as they're in the same VPC, same subnet, they will be able to communicate with each other, but outside world will not be able to communicate with your server, with your database server. So this is sort of what the architecture begins to look like once you lock everything down inside VPC. So the black one is the VPC. The DynamoDB and SQS, they're not really inside the VPC, but the connections are made from the application server. Then you have the RDS, the application, the web, and the Elasticache. They're really all inside their own subnets. And the web subnet is obviously unique in that while the other subnets the application tier or the RDS or database tier does not need to be publicly visible. Web subnet does need to be publicly visible. So that would be a subnet. They make that differentiation where there are private subnets and public subnets. So private subnet would be that does not have public IPs, cannot be accessed outside the VPC. So web would be one example where it will be a public subnet, whereas app and RDS would be private subnets. And once you're inside a VPC, one of the things that makes VPC a bit challenging to set up is that when your server does not have a public IP address, it's inside a VPC. If it doesn't have a public IP address, it does not have internet access, because you need a public IP address to actually have internet access. So what you're missing is an internet gateway at that point. So when you spin up a VPC, you also have to spin up a gateway through which all your instances inside the VPC can actually communicate with the outside world. So the traffic will have to be routed very much analogous to the router in your home. Yes, sir.
So if you really want to secure your app server to the web, you spin up an instance and just be like an Apache server or something like that, so that nobody can go in and encrypt and compromise your application server.
So you could actually put, like you mentioned, like a server in front of it, like the web server, which is Apache. There are actually better ways of doing it. Sometimes you would want a web server because you may be doing some rewrites of your rules and things like that. There are reasons to have an Apache server in front of app server. Other reasons, not this one. So in this case, I was actually thinking other reasons. But to answer your question, which is like, would we actually always need, say, an Apache server in front? The answer to that is a no. You would not always need an Apache server. There are other options with Amazon. One of them is a load balancer. A load balancer, you had actually brought it up earlier. A load balancer is typically thought of as something that does load balancing between servers. And that is a correct statement. But with Amazon, it's cheap enough. It's not like a F5 box that you have to go buy. So basically, what you can do is bring up a load balancer for $15 and put the load balancer in a public, what was that?
They put it in front.
And just put it in front and just put that inside a public subnet. So you could just always have that security that they'll have to somehow hack past the load balancer, past that subnet to get into your application tier. So just basic ideas to just have layered security. Any more questions about this VPC setup? So the NAT is, I would say, the setting up the NAT and the internet gateway is kind of what makes VPC a bit more challenging. If you guys have any more questions on how to do it, I can definitely talk about it offline. But how do you actually set up a NAT and just route all your traffic through it? But it's definitely a recommended practice. And Amazon's leaning towards where everything would be inside a VPC. So the last thing, this Amazon Cloud, we talked about, it's a utility. One of the biggest things that comes with the fact that it's a utility is the elasticity. It's kind of interesting to see how few people are actually leveraging the elasticity, which was one of the biggest selling points when you think about the cloud. In fact, I would say if in the sample of people that I would talk to, about 80% of the people that I've met are actually not leveraging the elasticity of the cloud. Where elasticity to me means if you have more demand, this infrastructure expands, and when your demand reduces, the infrastructure contracts itself. And because that was one of the biggest selling points to begin with, and why it's important, it can save you from spikes and performance hazards. It can save you money when your traffic is low. It can save you from having really bad load times or start throwing 505 errors on your server because your traffic, you were just tagged by /dot or something. So all of that definitely makes up for a good case. So let's talk about that for a second. So part of it, and I think this is where it becomes really interesting from the application development standpoint, because it does make a pretty big difference to the application development mindset. It's actually not so much the difference in the code, but the mindset, whether or not you want to leverage these scaling services. So Amazon's first thing, I would say, the first major thing they did was auto-scaling groups. Auto-scaling groups are this entity you create. So rather than creating a server, you create an auto-scaling group, and auto-scaling group takes in an image ID as its input, and you can specify, like, I want 4 servers, and the auto-scaling group would create 4 servers for you. But the key is that those 4 servers will stay inside this blanket of the auto-scaling group. So if I were to draw them, I would draw a box around those 4 servers. If one of those servers goes down, and it becomes 3 servers, Amazon will automatically restart the server for you and make it 4 again. And that's where the benefit begins to come in. Instead of getting a call or SNS, I assume when we talk about SNS and machine-to-man communication, a lot of you were thinking alerts that you get. Part of this exercise, and what I mean by elasticity, is to remove those alerts. So if you get an alert saying your CPU is 100%, convert, instead of having it as an alert, set it up to be a policy where the autoscaling group can just kill the server and spin up a new one. So the idea is to just put your servers inside autoscaling groups. Why they are called autoscaling? So I would almost say, if I were to rename them, I would actually split them up and say they're server groups and they're autoscaling groups. So what I have so far defined as a server group, I can define an image and say I want 4 servers, and it'll bring up 4 servers identical to each other and keep them up for me for as long as the autoscaling group is running. Now, why the name autoscaling was added, why the adjective autoscaling was added to them was that they also have another cool feature, which is that they can autoscale with traffic. So if you have more traffic coming towards your website, they can increase the number of servers, and if you have less, then they can decrease it for you.
Do they handle the DNS on the back end?
So the question is, how do autoscaling servers actually handle DNS?
Well,
And
how do we reach them?
how do we actually reach them? So autoscaling, we talked about load balancers earlier, which are sort of the idea of to distribute traffic across servers. So when you build an autoscaling group, you actually attach it to a load balancer, and all your traffic going to that tier would actually hit the load balancer, and then the load balancer will take care of distribution.
They handle it all for you.
And they'll do it all out for you. Literally one click, attach this autoscaling group to this load balancer, and it'll work for you. In fact, even one thing that jumps out from there is that the load balancers also have health checks associated with them. And so if a server begins to fail the health check, the load balancer can notify the autoscaling group, hey, one of your guys is not behaving well. Autoscaling group can kill it and restart it automatically. Talking about what kind of health checks, I think it's very interesting as well, because initially the health checks used to be just something as simple as, is there something going on at port 3306 on this server? Assuming that it's a MySQL server. If it's open, the load balancer would assume that if the port 3306 is open, that means this is good to go. And they've actually now introduced something very interesting where there's a health check which you can program the health check to make an HTTP call to your server, get a response back, do a regular expression match on that response, and then decide if the server is alive or not. So in your application, you can add a myURL/healthcheck.html, and your application can notify the load balancer, hey, something's wrong with me, and load balancer will take care of restarting that server automatically. So it could become, so even if you're not but one thing to notice, and the reason I differentiated between groups and autoscaling groups, they're really the same thing under the Amazon umbrella. But you may not want the autoscaling feature, because I get that a lot. When I talk about autoscaling, people say, well, our traffic is fairly predictable. I can tell with 100% accuracy what my traffic is. We don't need autoscaling. Well, you may not need the autoscaling part, but you still need the group part of it, which is the ability to restart things automatically. So that would be a fixed size autoscaling group. There are other things that Amazon has added that are higher level entities. So autoscaling groups were still dealing with servers. They also have this elastic Beanstalk. Beanstalk is a platform as a service. So where you basically they have like a Node.js stack defined, a Python stack defined, a Ruby stack defined. You can just push your code to it, and Amazon will actually just scale it for you. Anyone here using Beanstalk, by the way? So from a startup standpoint, it could make a lot of sense if your application is, the only challenge with Beanstalk as of 3 weeks ago was that you really had to fit in Amazon's shoe size, basically, because they would give you a pre-built stack, and you have to, if your application fits in that mold, you're good to go, because then they will take care of the scaling for you. You can increase the number of servers by just scaling literally on their website and say, I want 10, and it'll go to 10, and you push new code to GitHub, you just can make a connection between Beanstalk and GitHub with one click. You push new code to GitHub, it'll go straight to Beanstalk. New app will get deployed. Anyone here use Google App Engine, by the way? So they were a long time PaaS, platform as a service, have been around for several years. That's where I got introduced to PaaS. And traditionally, the challenge has always been with PaaS that you have to fit in the mold. You have to work with them, and there's a lock-in kind of thing going on there as well for you. Recently, I think it's a big thing, but Docker, is that term familiar? Are people familiar with Docker generally? So Docker is this idea of very lightweight, isolated environments like virtual machines. So Beanstalk has introduced support for Docker. So the idea is that now you do not have to fit in their mold anymore. You can take your application, build a Docker container, test it on your laptop once it works, take the same container and literally push it straight to Beanstalk, and Beanstalk will take it from there and just scale it for you. So you can install whatever application. If you want a quick basic application, you could put it there. And just as long as you push it, if it works on your laptop, it will work on Amazon, because you literally take the same environment and push it from your laptop. And I think that's revolutionary in that it really simplifies the continuous integration and delivery cycle as well, because you don't need to have a QA environment anymore or dev environment anymore. Test it on your laptop and just push it. As long as your application is simple enough and there's not a lot of dependencies on it. So that's what Beanstalk is. OpsWorks is another service from Amazon, which is also trying to do more than just auto-scaling groups. So they try to manage your servers, kind of manage your servers for you. So the integration they have is with Chef. So you could basically give Amazon, here's my code, and here is a Git repository containing all my Chef recipes. And then Amazon will create your servers for you and actually just scale them up and down over time. Are you guys, anyone here using config management, Chef Puppet? So it is definitely, it's actually on my slides on something you definitely want to be doing as soon as you can, especially if you're on a greenfield project, because it's really easy at this point. It'll become harder and harder going forward. So config management is the idea that you need to know exactly how your servers were created. Today you would think it's easy because there's only 2 or 3 packages that are installed on your server and you can recreate it really easily. Consider when time passes, your original employees leave. Over time, software versions change, software names sometimes change. Your documentation becomes stale, and you start running into this issue. In fact, I was consulting with a client just last night where they had a document they thought was how they deployed their server, and I actually had to deploy a server to reproduce a bug, and we found close to, I think, 6 issues with their documentation, just because there was a package that somebody later on and manually installed on the server and never really added it to the document, and things like that had just accumulated over time. Add to that the fact this was still the original guy, so every time I would say, I feel there's this package, it's giving me an error, and he would, oh yeah, I forgot to add that to the document. Now consider if that guy was not the guy I was talking to, he was the CTO, it's a 2-man startup. Once it's a 20-man startup, the original guy is no longer there anymore. It's a totally different story. So the sooner you have, so it's basically the idea is to script your deployment. You can do it as a bash script, that's the bare minimum. Much better to do it with one of these configuration management tools like Chef or Puppet. And in fact, if you guys are looking for a recommendation at that point, anyone here using Windows servers in their environment? So Windows guys have it a bit tough. You have to stick with Chef if you're looking at configuration management. I think Chef has the strongest support for Windows, where it can install packages and configure things like browser settings, etc. for you rather conveniently. For those using Linux, I would definitely recommend a new tool called Ansible. It's newer compared to Chef and Puppet, which are sort of the market leaders. But Ansible is substantially easy to work with. You can get a recipe up, and in my experience, about 1/5 the time. And it actually does a pretty good job, kind of accomplishes the same thing as Chef or Puppet will. So OpsWorks is basically, you give it a configuration management and say, this is how I want, this is what I need on my server. And Amazon will create the servers for you, install the packages, put your application code on there, and bring it up for you. However, when you're dealing with auto-scaling, this is where, when I said it's a mindset change from a developer standpoint, and since most of you are back-end developers, things that you definitely want to keep in mind. If you want your application to be able to auto-scale, it's very simple stuff, but keep that in mind that you have to be able to separate stateful services from services that are not stateful, because stateful services are not going to auto-scale. You cannot take MySQL and say, I'm going to just add more servers, or if a server dies, bring up a new one. That's not the nature of the beast. It's servers that have data on them, and you have to have a better solution for dealing with MySQL. But for Ruby on Rails servers or Node.js servers, they're not supposed to have any files on them. If you're actually putting files, you're making a mistake. If you're putting any state on the server itself, any files, that are pivotal, mission critical, you're making a mistake because your server can go away anytime, and B, you will not be able to auto-scale the service, the TL anymore if it's actually putting anything on the server. And the reason is that when a new server comes up in an auto-scaling group, it comes up from the same original image that you provided at the beginning of auto-scaling, when you set up auto-scaling. So if you since have added stuff that is important to the server, auto-scaling group is going to brutally kill that server and just replace it with a new one if that server goes away. And it's not going to care for any data that's on that server, and you're going to lose the data. So you want to be cautious to not have state. And it's not difficult, it's just conventional wisdom, but just be mindful of that. The other thing is, do not write code with IP addresses or host names on them. At least make them configuration options, so tomorrow if you want to auto-scale, then you will be able to write scripts that will set those configurations for you automatically. At least there's a possibility left. If you put in hard-coded host names and IP addresses in there, auto-scaling is going to become a nightmare. And auto-scaling does save a lot. I've seen savings on the order of 50% for a reasonable size infrastructure. So if you're talking about an infrastructure where you're saving $10,000 a month, it will be worth making those. These mistakes would cost a lot, basically, making at this time. And lastly, you need to be able to bake your server's images. And what I mean by that is that you have to be able to bake the image, and when you actually restart from that image, your service should just come up with it. Like, don't make it so that, and this is a very typical process where I bring up a server and I have an Amazon image saved, where I have an image for all the code is on there, but then I have to log into the code server and start typing commands to start all the services. Even if it's a single command, don't do it. Just make it so that the services just start on their own when the image comes up. That's a prerequisite for auto-scaling. And if, for whatever reason, it's hard to automate that process of bringing up the server, that's exactly what I want you to be mindful of. Your server, your services and everything has to be able to start up 100% automatically and very simply. So with that, our very list sort of gets taken care of from an architecture standpoint. So we now handle traffic spikes. We talked about security breaches. And we have, with auto-scaling groups, even if you're not using the auto-scaling feature of it again, that's only for traffic spikes, you can still improve the uptime of your services by using auto-scaling. So just sort of a final touch. This is what we ended up with from an architecture standpoint. In the vein, I just wanted to sort of also dive on how would you actually code for something like this. So kind of delivering the same point, but it's a very famous saying these days. Think of your servers as cattle, not pets. And what's the difference? The difference is that when you have a pet, the pet has a name. It's actually cared for, and most importantly, when it's ill, you actually try to fix it. When you have cattle, you don't do any of the above. They're not named, they just have IDs. They are identical to each other. They are considered as disposable resources. That's exactly the way you want to start thinking about the servers. And what allows you to do that is Amazon, or any of the cloud providers for that matter, where you can take an image, restart a server. You never have to try to fix a server. The idea is that if I want a patch applied to a server, why bother applying a patch? Why not just create a new server, make sure it's working, and then kill the old one and put the new one in its place? You have a load balancer that the servers are attached to. Remove the old server, put the new server in. In fact, companies like Amazon and both Amazon and Netflix, they don't even try to push new code to the server. They just, every single release of software, and Netflix does about 1,000 releases a day, I believe. At every single release, they just kill all the old servers and just bring up new servers. They don't bother actually fixing the old servers. And in the limit, once you actually get to that level, once you have the plumbing and the mindset figured out, really, it actually makes life a lot easier, because a lot of the operations nightmares happen when you try to apply patches. That's where 90% of the issues occur, is when you try to apply a patch, one of the servers gets patched slightly different than the other one. Now you have asymmetry, now you have bugs that you have no idea where they're coming from. So if you actually take this best practice into account and never try to patch something, think of them as, since you guys are developers, you guys will get my developer spiel simple. Think of them as immutable variables. These are servers are things that you cannot change. Once created, they can only be destroyed, not updated. And if you think about it that way, it does improve the durability of the service you're trying to provide significantly. And one of the other advantages that comes in is what they call the blue-green setup, where every time you have a new version of your code, bring up a new server, set it up, you can test it, and then after testing the server, you actually put it into production. And it's literally the same server, so you don't have the mismatch problem from, oh, it worked in QA, but it's not working in production. It's literally the same entity that moved. So you could do QA on the production server and then just on the about-to-be production server and then just put it in production. Another thing that Netflix actually does very well on this, and I think Amazon Video on Demand does it really well, from my knowledge. They also use it for A/B testing, because they're doing 1,000 releases a day. At any point in time, they have tens of releases in flight at the same time. So when you and I hit Netflix at the same time, there are minor differences, but we could actually be looking at 2 different versions of the app with differences in between. And really, there's A/B testing going on between the servers, and at any given point in time, they're using production as their QA, because a new version got pushed, like immediately 5% of the servers get updated with the newest version that just passed QA. And then they just monitor the error rates on that 5%. If it's not higher than any of the other versions, they start increasing the share of that version, and that sort of starts becoming the main of the a major version. So it's a very different way of thinking about it, but yeah, keep that in mind. Servers are immutable. You do not try to update or fix them. Yes?
So you don't have any more staging servers, you just work on one, make sure it works, and then you create an image, and then bang, you just put this in production?
Once you have your plumbing figured out, that's actually the case. You could just do it that way, and you put like just enough monitoring so you know if this new version is just giving more errors than the previous version. The rollback is easy, just kill the new server you created. So yeah, server is sort of the entity that you can now control. It's no longer just the code. So servers, we always used to think of them as the static thing. It's no longer the case. So a few things.
I got a question about, in this mindset, can you touch on, do you ever have problems with software licensing?
So software licensing, Amazon's very actively working on that. So yes, the answer is, repeating the question, do you have problems with software licenses in this model? With traditional software, yes, there are challenges. Amazon is actively working to fix those challenges as well. So Microsoft, they have it almost figured out. You can spin up Windows instances. You can have Amazon workspaces with Microsoft Office in them and use it on demand. There are some traditional licenses that are just tough ones to crack. So there are some tough ones, like we are actually dealing with a company that has a pretty big presence in town. In fact, Silicon Company, Austin's big on silicon companies. EDA licenses, because they're using licenses from like Synopsys and Cadence. And Synopsys and Cadence have year terms on licenses. It's not even monthly or daily terms. And here we are talking per minute licensing rather than per year licensing. So that was one of the biggest hurdles on migrating or working with the client and trying to figure this, because it was not the technology, it was actually the licensing and changing the mindset. But it's definitely working, and one thing that was pleasing to see was in the process when we were working with the client, how actively Amazon was actually nudging Synopsys and Cadence on their part to see if they can actually get something to work out. So Amazon's doing a very good job there. So just some takeaways from the developer side, since you guys are mostly developers. Servers are cattle, treat them so, don't fall in love with them, don't name them, don't try to guard them. You can try to use an existing service whenever it's possible / feasible. I should really add word feasible here. Don't mix stateful and stateless services on the same servers, because they will prevent you from getting all these other goodies about autoscaling. And then try to script application deployment or use configuration management, as I mentioned. The bare minimum you can do is a bash script. That actually goes a long way, by the way. But if you really want to do it right, and if it's a greenfield project, it will be really simple to do config management, and you can use Chef, Puppet, or Ansible. And lastly, local developer environments becomes more of a requirement as well with Amazon. You could do it with a remote environment, but when your developers have to log into a remote environment to test, it basically is there's a latency that you are dealing with continuously. As the type of key, there's a latency. So it's good to have at least some part of the development brought in locally. Just briefly, I was going to touch on this. So basically what the developer workflow looks like, so you have the developer, local testing, QA, production. So this loop that your developer works in first, which is the developer to the local test, by far the most expensive loop, because the reason is that your developers are, and this applies to startups more than any other company, I would say. Developers are really your only resource at this point. They are by far your higher. If you're expecting a big jump tomorrow in your evaluation, what's going to cause it is your developers. It's not going to caused by you buying some outside service or a SaaS product from somewhere. So they are the highest ROI resources. You may not be paying for their hours, but you're actually, they have the biggest price tag on them. So you need to be managing them very cautiously. So that's your first loop, and that's why I call it the most expensive loop. QA is somewhat in the middle. Production, that loop is extremely expensive in that if you have a production bug, it can lead to all kinds of issues with your clients, your customers, lack of confidence, stakeholders, your investors could get involved at some point if your website continues to go down. We all saw what happened with the Obamacare website. So it's the most expensive, ideally least executed loop. And what I'm trying to deliver is that the developer, this loop is actually something you want to optimize. So yeah, it may seem like you can just have Amazon, have your developer environment in Amazon and they can type code over there. Or you can have an environment where the developers just approximate production to a reasonable extent and just work over here. The problem with both those approaches is in one case, this loop will slow down, and in the other case, your more expensive loops will get executed. For example, if there's mismatch between your local environment and your QA environment, your QA loop will get executed quite often. Your code will go and come back to the developer. And this is more expensive than when the developer is actively working on this, because there's a context switch overhead too. Lastly, you also have the production loop, which is even more expensive. So mismatches are important to avoid. So it's a much longer discussion, but let me just quickly jump to it. So something that has worked for us with our clients in the past and done very well is set up your laptop, set up a virtual machine inside. Inside the virtual machines, you can use Docker, which I mentioned is a way to do lightweight containers, and put your production applications, the different tiers of it, each tier inside a separate Docker container. This is actually important because you're actually getting very close to production if you think about it. You're taking the exact same software that you installed on production, installing it inside a container, which is a lightweight virtual machine, and just creating different tiers from it, and just connecting them like production. And you can use the same scripts that you're using in production in most cases. Provide the right interfaces for your developers, and I think this is actually a very key ingredient that your application servers using VirtualBox and Docker could actually share code or share the same folders with your laptop. And the reason I find that very important is your developers know how to use their editors. They have their favorites already, they have their shortcuts memorized. This allows them to use their favorite editor on their laptop at real-time speeds. The code is shared all the way in through the container to the application, through the VM to the application container. The developer makes a change out here on their laptop in Emacs or VI or gedit or whatever they like to do. The code goes in, the application server restarts, and on their laptop, the developers are able to see the result. You could have outside dependencies if not every service could be replicated in here. It could go to Amazon and come back. But the idea is that you can allow your developers and your application tier to stay on your laptop so that you could allow real-time speed coding and get really quick feedback without actually having to create remote dev environments and share them between multiple developers. Like I said, it's a longer discussion. I won't deep dive into it, but there's actually a longer version of this particular talk here at the link. So lastly, how to manage. So there's some sort of new world problems. So how do you actually deploy code? Sorry, pull this one back. So last thing I wanted to talk about was how would you actually manage this environment that you've created, because it sort of impacts that. So when you have a dynamic environment and your servers are your cattle and not your pets, a lot of things do change from interfacing with this environment. So you no longer have static IP addresses, you no longer have fixed IP addresses. So what that implies is that some of the things that used to be trivial, like deploying new code, deploying new code, typically either you're SSHing into a server, or you're using Capistrano if you're on the Ruby side, or using Fabric on the Python side. Any one of those solutions, or a bash script with just SSH or SFTP new code and restart the service, well, all of those assume a basic thing, which is you know the IP address of the server, but or your server has a name attached to it. It does not have that anymore, so you have to come up with a solution to that. And as I mentioned, one of the most effective solutions is just not trying to fix your servers, just treat them as immutable entities. When you have a new version of the code, just create a new server and just kill the older one. Actually works out very effectively. Then we have how do you actually configure the servers in this dynamic environment if you want to install patches? I guess my answer is do not try to do that. Don't try to install patches. Yes?
So for moving code to a new server instance, does that mean that you have to rebake your image with the new code in it?
Oh, that's correct. That's exactly how Netflix does it. In fact, they have an entire blog post dedicated, and they also open source some of the code that they actually use to create. They have a tool called what they call Aminator, A-M-I-nator. So Aminator is a tool for baking AMIs quickly with new code, new versions of the code. So, so basically, how do I manage and patch my servers? Well, don't try to do that, because again, just creating new servers is the easier way of doing it. If you really want to, configuration management really helps there, but there's really no need. And lastly, and this question was brought up earlier, like how do you create and recreate environments on failure? And this also applies to if you want to create a staging environment or a dev environment. Now that we are dealing with servers and we've talked about creating all this cool stuff with VPC and auto-scaling groups, a very key component of all that is that all of that we built or architected earlier, yes, you can go to the Amazon console and click and build it. But alternatively, you could just write, and there's a service in Amazon called CloudFormation templates. CloudFormation is basically it's a way for you to script the creation of your environment in the cloud, in the AWS cloud. So you could literally write a script. CloudFormation has their own sort of language that you would write in, and once you get a hang of it, it's a bit verbose, but it's very all-encompassing in terms of the API. And you can literally take your entire environment and just script it in a single text file and say, I want 3 DB servers, I want 2 RDSs created, I want 2 S3 buckets created, I want a caching distribution layer put in front of it. And this entire thing can be put into a single template. Once you have the template created, so again, something that if you are in it for a long haul, or you kind of value your time and you feel that if you have to do this again, you will actually waste time, it's worth putting the investment up front and just putting everything inside a CloudFormation template rather than creating the servers by clicking through. If you just put it in the template, the advantage is if you have to recreate your environment, it's just one click. Your template is saved. You just say, create this. Amazon calls it a stack. Create a stack for me, and it'll just create another stack. And if you want a dev stack and a QA stack, create it is just 2 clicks. You tag the stack, and it just brings up the entire thing for you. And every single resource in Amazon can be attached and created as a part of a CloudFormation template. So it can include S3, SQS, whatever service you're using. So a very big time saver, also helps in disaster recovery, because if you have to recreate the environment, or if Amazon's region or zone goes down, you can bring up your environment in a different region. Other things that we have learned, and we've already hit on configuration management. The other thing I meant, absolutely, and do this as soon as possible if you can, set up continuous integration and continuous delivery. The sooner you do it, the better off you would be. And again, it's not a success problem, and I can tell you from experience, having worked with tens of clients. As a startup, you would actually see the benefit right away, and just take the effort to set up continuous integration, continuous testing as you deploy code, and just getting the code straight, at least into the staging environment. There are services out there which are making it really easy right now. The two that I've seen people use are Circle CI and Travis CI. Travis is a little more expensive, but it's more featureful. But the idea is that if you specify, even if you're not writing automated tests right away, it's a good idea to channelize so that your code is delivered through one of these services. So tomorrow when you create a /test folder in your repository, it will start running those tests for you as soon as your code is pushed in. And if you do it early on, then you can sort of generate this culture at your company going forward where people will start writing tests. So highly recommended. Thanks, that's all I have. More questions?